Alright, so for 3, 5, and 3, 6, we're actually going to do these together. And these are continuing our trig functions, but for beyond the first quadrant, as well as quadrantals. I'll put obtuse angles. So one of the first things that we need to talk about in terms of trig functions for quadrantals or obtuse angles is we have to go over the idea of a reference angle. So a reference angle is when we have an angle. So if I say this is 30, so theta equals 30 degrees, and over here, let's say I have this angle is 150 degrees. These two have what's called the same reference angle. The reference angle is always measured from the x-axis. So whether it be you're measuring from the x-axis up, the x-axis down, as long as it's coming from the x-axis, either going up or down, you're looking for angles, the reference angle that has the same as what your acute angle is. So here, these both have a reference angle of 30. This angle is 30. This one, the measure from the x-axis to the terminal side, is also 30. And so one of the things that's great about reference angles is that we can use a simple sine pattern to be able to figure out its trig values. So I know many of you guys have already kind of talked about it, but we have in quadrant 1, all of our trig functions are positive. So when we come over here for 150, if we were to make our right triangle, knowing we have a 30-degree reference angle, then we have a 30, 60, 90 on this side. So if we remember from yesterday's notes that cosine of an angle is equal to x and the sine of an angle is equal to our y value. So again, we have a unit circle of 1. So when we talk about positive 30, our opposite was 1, our opposite was 1/2, our adjacent was √3/2, and then our hypotenuse was 1. So we're going to have these same values, but over here, we're going to notice that our x value is going in the negative direction. So we're going to have negative √3/2 for the cosine. And we're going to have positive 1/2 because we're still going up in the positive y direction, with our hypotenuse still being positive or 1. So when we come to our unit circle over on this side, the only one that's positive is sine. Our sine, because even when we do cosine, we'll have opposite over adjacent, we're still going to have a negative value. So all of them are positive, only sine is going to be positive over in this quadrant. We can do the same process for each quadrant, and over here we'll get tangent is the only one that's positive, and over here we'll get cosine is the only one that's positive. So we're going to have the same numerical values. The only thing that's different is going to be the sign of the value, S-I-G-N, not S-I-N. So the sign S-I-G-N of the value is the only thing that changes, depending on which quadrant it's in. So I know a lot of you guys have again already heard this. All students take calculus is a good way to remember the order. Just know where you start and where you need to end. So in other words, start in quadrant 1, end in quadrant 4. So again, that's kind of the idea for filling in the rest of our unit circle. So what we're going to do, or what I want you to do right now at home, is see if you can hit pause and fill in the rest of your unit circle so that tomorrow in class we're just going to go over it to make sure that everything's in the right spot. One of the things you'll notice if you haven't done already is to also put the equivalent radian in it, so that way you guys have that readily available on your circle. Okay, so go ahead and hit pause, and then when you're ready to come back, hit play. So the rest of these notes technically go with 3-6. So 3-5 was just this part, filling in the unit circle. And in class, you're going to get a worksheet where you're just going to be using this unit circle to help you answer a bunch of sine, cosine, tangent questions. And you're going to find the values. One thing that we don't put on our unit circle that you might just want to keep in mind, I don't know if you want to write a note to the bottom, is we're also going to be doing the reciprocals. So the reciprocals follow the same pattern. So the reciprocal of sine is going to be positive only in this quadrant. The reciprocal of tangent is only going to be positive in this quadrant. The reciprocal of cosine is only going to be positive in this quadrant, and then all of them will be positive in the top quadrant. So even the reciprocals will follow this all students take calculus pattern. So 3-6 is where we're going to take more of these and just, again, practice with our unit circle. And sometimes it's going to be helpful to sketch out what we're being given. So just to kind of touch base a little bit on our unit circle and think of things a little differently. And what I mean by differently is in terms of an ordered pair. So here we have an angle theta. Now, for the purposes of our unit circle, we know that the radius is always 1. But what if we're given an ordered pair that's like 4-2? Now, obviously that's not a 1, but we can still figure out its trig values based on the ordered pair. So if we're given an ordered pair here, x, y, we can still draw out the right triangle. We can use the fact that sine is positive, cosine is positive, and so is tangent. And so what we might need to do is figure out our radius, because now our radius might not be 1. And we have to remember that cosine is x and sine is y. So when we talk about sine of our angle, we're going to be talking about the opposite, y, over the radius. Our cosine of our angle is going to be the x value of our ordered pair over the radius. Our tangent is going to be y over x. So it's the same ratios, we're just putting it in terms of an ordered pair in case we're given it in that form. Now if we're given it on a unit circle or an angle from our unit circle, we don't have to worry about this. But we do sometimes get points that aren't on a unit circle because their radius is much bigger than 1. We can still use the same ratio using what we know x and y are, and then using Pythagorean theorem to help us find the hypotenuse so that we could then find our ratios. So again, we can do the reciprocals as well. So r over y. Our secant would be r over x, and our cotangent would be x over y. So again, these are just more for if it's not an exact angle or if we're given an ordered pair, we can think of our trig functions in this way. So when it comes to actually evaluating, this is what it's going to look like on your 2 worksheets for tomorrow, because we do have 2 worksheets tomorrow. It's going to say to evaluate. So number 1 will say something like cosecant of 3 pi over 2. Okay, so we have to think of, okay, what does that mean? Well, we have to think of where is 3 pi over 2? So if we're on the unit circle, 3 pi over 2 is a quadrantal angle. This is our 3 pi over 2. So 3 pi over 2, this is the same as 1 over the sine of 3 pi over 2, because it's the reciprocal of sine. So if we can figure out sine, now sine again is our y value. So the y value here on the unit circle is -1, so we would have -1. So for the quadrantal here, we'd have 0, -1 as our cosine and sine. So this one's one of the weird ones that's going to be a 1, a -1, or a 0 in terms of what our outcome is. So if you haven't done the quadrantals, this might be a good time to stop and fill those in using what you know. So if we were at pi over 2, again our sine is +1, our x value is 0, so our cosine is 0. Over here, if we were to do 0, we'd have an x value of 1, so our cosine would be 1, and a y value of 0, so sine would be 0. And then for 180, we would have an x value of -1, a y value of 0, meaning we'd have a cosine of -1 and a sine of 0. All right, for the next one, we're going to do tangent of 180. So we have to think of, what does tangent mean? So tangent is sine over cosine. So we just wrote up here what our sine and cosine were. So sine is 0, cosine is -1, so that means we're at a tangent of 0. Secant of -270. Okay, so let's think of, where's -270? We're going to start at zeros, at the line 0, but we're going to go clockwise, because that's the negative direction, 270 degrees. So that's actually the same as 90. So if we were to do the secant of 90, we'd get the same angle. So secant is 1 over cosine of 90. So that would give us 1 over, so cosine here is 0, so that's actually undefined. We don't have a value for it. Next up, we'll have tangent of -2 pi. So again, on my picture, I'm going to try to figure out where is -2 pi. So start at 0. 2 pi is a full rotation, so I'm back at 0. So tangent of -2 pi is the same as tangent of 0. So tangent of 0, I already have my sine and cosine. So I have sine, which is 0, over cosine, which is 1. So I would just get 0. Okay, next one, we'll have the cotangent of 90 degrees. So cotangent of 90, that's 1 over the tangent of 90. So if we think about, or if you want, you can think about it as cosine of 90 over sine, so just the reciprocal instead of 1 over tangent. So again, we already know what our cosine and sine are because we filled them in up here. I know it might be hard to see. So our cosine here is 0, and our sine is 1, so our cotangent of 90 would be 0. So when I was doing these, I didn't redraw this picture every single time. Sometimes it might be helpful to draw a little coordinate here and go, okay, cotangent of 90, that's here, or secant of -270, that's here. That way you can remember how you got these equivalent values. It's something that's a helpful tool just to draw it and to be able to see it. But this right here is pretty much what you're doing on both worksheets. So you're going to have one that has a bunch of these mixed in radians, and then you're going to have some where it is going to be reciprocals, where you might have to use this idea we did here of finding an equivalent positive angle to help us figure it out. But this is pretty much it. It's just practicing using these different forms and using that unit circle to help us get there. So there is one more I want to do that's like something on your 3-6 worksheet. And that is, it's going to ask you to draw your angle. So this is one of the ones where I'm going to ask you to draw. So draw the angle and find sine, cosine, and tangent. And all you're going to be given is an angle. And so with this, you're going to have to do, again, a little bit of critical thinking, but it all is going to come back to that unit circle. And it's going to become something off of that unit circle. So when I look at this, I'm going to start by sketching the angle like it asks. So here's my coordinate plane. So 2 pi over 3 isn't quite pi, so I know it's going to be somewhere in here. So here's my 2 pi over 3. If you remember what angle that is, that's great. You might think of it as, let's see, 2 pi over 3, which means this reference angle here, in order to make 1. So I'd go pi minus 2 pi over 3, because remember in radians this is pi. I'd get pi over 3. So I know this angle, my reference angle, is pi over 3. So when I go through this, I can think, okay, what is pi over 3? Pi over 3 is equivalent to 60, so I have a reference angle of 60. So when I'm going through this, I'm going to, again, also use my all students take calculus to say that sine is the only one that's going to be positive here. Every other one has to be negative. So when I find my sine, I'm going to think, what is the sine of pi over 3? Because sine of 2 pi over 3 is going to equal the sine of pi over 3. So let's see, what is sine of pi over 3? Go to my unit circle, it's root 3 over 2. Now cosine of 2 pi over 3, that's going to be the negative version of cosine pi over 3. Okay, because cosine's negative over here. The numerical value is the same, but the cosine is negative. So negative cosine of pi over 3 would give me negative 1/2. And then lastly, tangent of 2 pi over 3. Again, we're dealing with the negative version, tangent of pi over 3. So I'm going to think, okay, what's tangent of pi over 3? Or if you want, you can even use your cosine and sine values here to use sine divided by cosine. So sine is root 3 over 2 times the reciprocal of cosine, because when we divide, it's the same as multiplying by the reciprocal. We get negative root 3, and there would be your tangent. So however you need to think about it, this is what it's asking of you on the second part of your 3-6 worksheet. And this is something that we're going to come to later when we talk about even and odd, is noticing how sine is the same in these first two quadrants, but everything else is opposite. When we talk about the graphs later, even graph, odd graph, because of that opposite idea. So again, if you have any questions on 3-5 or 3-6 or filling in your unit circle, ask them before we get started. Because really that's what we're doing in class, is we're going to be working on our unit circle and evaluating all of these different things. I didn't have it on there, but I do think we're going to do like a little quick quiz on our trig facts. So if you guys are, and we'll only do it if we have time. So if you guys are wanting to really practice memorizing, I know that there's hand tricks out there, there's noticing patterns. However you need to do to memorize it, have it memorized, because we're going to do at the end of class just a quick little trig facts quiz to make sure you guys are doing okay with that.